All right, here we go. So I'm going to be looking at showing you how to do some of these questions on right triangles. And the first one, I'm going to be using understanding that if I have 2 out of 3 of the side lengths in a right triangle, that I can use Pythagorean theorem to find that missing side length. So here, I'm going to use a squared plus b squared equals c squared. It doesn't matter where you put the 15. It can go into the a squared or the b squared as long as your hypotenuse 20 goes into the c. So I have 225 plus b squared equals 400. Move the 225 over, get 175. Take the square root of both sides, and you get our side length is the square root of 175. If you wanted to reduce that, you could, or I'm going to go to my Desmos calculator. See, I've already kind of done some work here. Had some issues with Loom, but we're getting it. We're figuring it out. Square root of 175 is approximately 13.2. All right, so that is going to be my side layer. Now, the next one is I don't have 2 out of 3 of the side lengths, so I can't use my understanding of Pythagorean theorem, but I can use my understanding of right triangle trigonometry, or SOHCAHTOA, to help me solve for these 2 unknowns. So if I use this idea of 35-degree angle and go across or opposite the triangle, this would be the opposite side, and this 15 is what we call the adjacent side. Remember, the side length that's across from the right angle is always the hypotenuse. So in this first one, I'm going to find the opposite side. I'm going to be using my understanding of tangent. So tangent of 35 degrees is equal to the opposite side, which I don't know, over the adjacent side, which I do know, which is 15 units. If you wanted to use a variable like a, b, x, whatever, or a question mark, that's totally fine. To solve for that missing value of the opposite side, I'm going to go ahead and multiply both sides by 15. So 15 times the tangent of 35 degrees equals that opposite side. So going to calculator, I'm going to make sure you hit the wrench to make sure you're in degrees. If you opened Desmos for the first time, or even just checking calculator, Desmos always defaults to radians, so make sure you go to degrees if you're using degrees. So 15 times the tangent of 35, or 10.5. So 10.5 is the approximate value of that opposite side length. So this is roughly 10.5. Now, what I'm going to caution you is, I know some students will see that they've got 2 out of 3 side lengths now, and they'll think, oh, I can use Pythagorean theorem like the first one. I want to say, no, don't do that, because if you're going to use Pythagorean theorem with this 10.5 number, that's not actually the value. Feel free to use the Pythagorean theorem if you're going to actually use 15 times the tangent of 35 degrees. That's the actual value. But most students are not going to do that. Most students will probably just use another trig ratio to solve for that hypotenuse. All right, so I like to tell students, if you can avoid it, try not to use any rounded values while you're doing your calculations. So I'm going to go back to that 35 degrees. All right, I know I'm going to still be using 15. That's the adjacent side. Now I'm going to be solving for the hypotenuse. So the trig ratio that involves adjacent side and the hypotenuse is cosine. So now I'm going to write the cosine of 35 degrees equals the adjacent side, or 15, over the hypotenuse. Now, most teachers will tell you to put this over 1 so you can make a proportion, and then do cross products and set them equal to each other. That's your call. You can also just use your understanding of algebra to move that hypotenuse out of the denominator. Whatever you want, it's up to you. So I'm going to write down hypotenuse times the cosine of 35 degrees equals 15 times 1, which is 15. Then to move that cosine to the other side, I'm going to divide it. And so now my hypotenuse is equal to 15 over the cosine of 35 degrees. If we want to get a decimal approximation, let's do 15 over the cosine of 35 degrees. So 18.3 is the approximation. All right, so now we found those missing sides. Now, the next two, you're going to see, we can use SOHCAHTOA. You can always use SOHCAHTOA if you have a right triangle. But in this case, we're going to use understandings from geometry, where if you have a 30-degree, 60-degree, 90-degree right triangle, then you actually should know, or maybe you'd have to look it up real quick and review, but you were taught the relationships or ratios between these three sides. So the one that's across or opposite of the 30-degree angle is going to be your x. The one that's across from your 60-degree angle is going to be your x times the square root of 3. And then your hypotenuse is going to be 2x. All right, so in this case, since I actually know one of these side lengths, I can set this up as an algebraic equation, as x times the square root of 3 should be equal to 15. By dividing both sides by the square root of 3, I will get x equals 15 over the square root of 3. I know your algebra teachers taught you guys to rationalize the denominator. So multiply the top and the bottom by that square root of 3, which gives you 15 to the square root of 3 over 3, which is the same as 5 times the square root of 3. So you can feel free to leave it like that. It is one of our missing sides, or if you wanted to get an approximation, you could, as 5 times the square root of 3, which is 8.7 approximately. Again, at this point, I'm going to keep using that relationship of the 30, 60, 90, and I'm going to multiply to find the hypotenuse. I'm going to do 2 times that 5 times the square root of 3, which is going to be 10 times the square root of 3. If you wanted to write the approximation for that, you could. 10 times the square root of 3 is 17.3 approximately. All right, so that was a review of our 30, 60, 90 understanding from geometry. Now let's do the last one. The last one is a 45 degree, 90-degree right triangle. All right, and for that one, you were taught that both side lengths that are across from the 45 degrees have to be the same, and those are the same as x, so this will also be 15. And your hypotenuse is going to be that value x times the square root of 2. All right, so we'll be bigger than those two. So your hypotenuse is going to be 15 times the square root of 2, which you can leave it like that. Or if you wanted to get an approximation, 15 times the square root of 2 is 21.2 approximately. All right, so that was a review of, I switched to eraser. There we go. That was a review of some different ways to solve these triangles to find their missing sides. We did one with Pythagorean theorem, a quick review of triangle trigonometry, and then finally we looked at using our understanding of 30, 60, 90, and 45, 45, 90 triangles. All right, so now that you've seen this, make sure to attempt the homework and submit it to Canvas. Thanks.